Benz. I'm a SolidWorks employee, but I'm just from Salt Lake, so I'm nearby. I'm not muted here though. Can they hear me?
Yeah, we can.
Excellent. Perfect. Yeah, let me get this stuff out of the way too. I've been with SolidWorks years, and I was with a reseller for about 15 before that. But this is really what I like to do. I don't get to use my engineering skills much anymore. So since Halloween was recent, I take my son's first robotics leftover parts. It's 22 now, so he doesn't use that stuff anymore, and turn it into Halloween robots. It's only 2 parts on that thing that were made in SolidWorks. Most of it was purchased or wood or just scraps, you name it. But that's a little bit about me. I spent only 3 years out of engineering school actually doing real engineering. Started using SolidWorks in the 98 plus release. Was an AutoCAD user before that. Worked for a ski lift engineering company in Salt Lake. So I would have loved the multi-body stuff because I was doing all my assemblies of these big structures just with SolidWorks assemblies. Yeah, and the multi-body stuff would have been amazing. They didn't release that until I wasn't really doing real engineering anymore. So I've got a couple things to cover, and I want to keep this a little bit, well, a lot informal. So the topic is surfacing. So I'll throw out a couple things, but I'd be curious to know how much of this stuff you guys use. Is it, feel like it's way out of your realm? And then I'm going to show you something that's newer. If you haven't seen the 3D Experience online tools, I'm going to show some surfacing you can do with X-Shape, one of our 3D Experience tools that are available either in the Maker license or in, if your company owns 3D Experience SolidWorks Pro, it's included in that. So I'm curious, out of the group, who feels like they're, let's say on a scale of 1 to 10, who feels like they're at least a 4 with the surfacing tools? Okay, all right. Okay, how about, okay, we'll push it a little bit. How about a 7? Oh, I like the modest hand over here. It's a little, maybe. Okay, cool. Well, I've had times in my career with SolidWorks where I've had models that I just could not finish with SolidWorks. And now with some of the tools they have now, I wish I would have had them back then, but it's pretty cool. A lot of people think like surfacing is only for really complex stuff, where like, for example, if you're trying to build this helmet, the kind of the classic surfacing approach is you build every unique shape independently, you trim them up, and then you blend them together to end up with something that there's just no feature in SolidWorks to be like the football helmet feature. And I also apologize if you've seen this presentation in a webinar, because one of my colleagues put this together. It's excellent material, but so sorry if you've heard that pitch before. All right, there's no, you get some shapes. I mean, I see a bunch of them around in here. If you have to model some stuff that's complex, there's no one feature for it. So sometimes the surface modeling strategy is just right for the thing you're trying to do. Other times it's a fantastic tool. I remember years ago, somebody, he was a guy that did a lot of 3D printing, and he was like, man, SolidWorks just needs like the Bondo tool. And so I'll show you what I would call the SolidWorks Bondo tool tonight as a little tip. But there are a bunch of surfacing tools, and most of these, you'd probably recognize how to use them just from the icon. I mean, extrude, revolve, sweep, loft. They're pretty much the same things you would use, but you do have to put a little more labor into the activity because, again, solid extrude is fantastic because it takes care of all the knitting and creating a solid and everything for you. You don't ever have to think about it. But I'm going to focus on a few of these. I don't know that I'll get to all of them, but I want to show you a few and just kick over some questions. But just for the everyday SolidWorks user, these are great when you have to import a part that's got problems or you need to tweak and adjust. I would say for power editing, for tough shapes, just case in point, I had to make a complex plastic injection molded part for a doctor. This was a long time ago, back in the early 2000s. And there was a, let's see if I can describe this well enough. There was just a snap clip on the part, but it was probably made of, I don't know, 200 features or more. And after we got it molded and we're trying it, it wasn't right. We needed to move the snap clip. And I realized, to parametrically edit that snap clip and just move it up just a little bit was going to be really painful. So I just used the multi-body method and chopped it off, split the bodies, moved it, knit it back together, done. Okay, it's not the most elegant, but sometimes you just got to get things done quickly, right? Tough shapes is the obvious one. But for example, I'm going to show you a couple of these. Like delete face is probably my favorite, just handy, quick surfacing tool. Maybe a bunch of you have already used this. So maybe this is kind of the duh example. You import something, if you want to recreate those holes, well, you just use delete face and it's got a delete and patch option and they're gone. Now you can recreate them the way you want. You want to get rid of the fillets and add your own? Great, delete face. Get rid of that. You want to recreate the boss? Great, delete face. Super easy. For sheet metal, you can take something that's been imported, and I'm going to show you a couple of these examples. This is just for a little preview. You might have something imported, and Creo models are notorious. Their sheet metal does not create continuous radius curvature bends. They're variable radius curvature bends. Not all the time, but often an imported Creo part. So insert bends doesn't work to flatten them. So I'll show you how you could handle something like that if it's imported and you just can't use insert bends. It still won't flatten. So let's take a look, and I'm gonna, the general idea though, is you can, let me step back. I'm gonna show you this, but you can take the primary surfaces and basically copy them. There's an offset surface option. You just give it an offset of 0. It copies all of those into surface bodies. You often have to extend or trim surfaces to one another. You have to do a little bit more of the work. So this is an example of extending them, or there's even an untrim option that will maintain the continuity of the surface when you expand it. And put some fillets on there, thicken it out, because before it's just 0 thickness surface. And now you can use insert bends and you're in good shape. So, okay, it takes a few more steps, but if you need to do it, these are the kinds of tools that can be really helpful. So let me jump through a couple examples there first. Like this is a classic. Got a plastic boss, and I had to add obviously this is fake, but you have to revolve on some standoff or something inside, and well, okay, the revolve happens to stick out the back. You can't really do a partial revolve here because you need it on the inside. So yeah, I mean, you could just do another revolved cut out here. I've seen people like roll back before the revolve and copy the surface, revolve it, and then use the surface to cut. Yep, that works too. But it's much easier if, where's my roll to end? It's much easier just to use delete face. So let's pick those faces. And it's on the direct editing toolbar, it's on the surfaces toolbar, but it's also on the right click menu because it's just so handy. I'm going to expand that and just go to, oh, no, there it is. Sorry, I need my glasses for distance, but up close they kill me. So I'm going to take them off. And there are several options, but we're going to first focus on just delete and patch. What it does is it looks at the surrounding faces, and if it can just make them continuous, it's done. And when I get to the example of the SolidWorks Bondo tool, it's really just the delete face tool. but with a little bit different option. So that can be really handy if something's just, you've made something inside and it's kind of sticking out the outside, fine, just use the delete face on the outside. Have any of you guys done that before already? Is that was that just an obvious one? Maybe. Let's see. Well, here's another quick one, right? In this case, I have a hole wizard hole at an angle. So I want the tapped hole, and I ended up making a plane to start the hole. And I wanted it to really start my depth of the hole from the center. But now I've got a problem because I've got a face sticking out here. Yeah, you could just convert entities on the inside and make it cut out. But you can also do that a little more cleanly by just grabbing that face. Right, we'll do a little select other, get that one. And if you can't find it, I'm always a fan of the S key bar, so I can just do a search, delete the face. Same option, just delete and patch. Okay, now that continues that same face. It just gets rid of the extra. Pretty handy. A lot of places where that thing can just help you clean something up. Any of you had to deal with an imported sheet metal part that just wouldn't flatten with just insert bends? I don't know. That comes up very often. No, never. I don't know. How many of you guys do sheet metal? Okay. Well, let me just show you a handy little tool as well. You ever looked at face curvature on a radius to figure out what the radius actually is on an imported part that's curved, so you don't have a nice edge to find it out? You can use curvature display, and then you can tell what's the curvature or the radius. The radius of curvature is actual. It's like this thing ranges from 13 millimeters down to 5 millimeters radius. It's not. Oh, it's not a real radius, right? It's variable. So if I just try to use the sheet metal tools and insert bends, not going to work, right? Because it says, I don't know what that is. I can't find any radius. So, this is a place where you could take all of these kind of main bodies, main faces, let's say, and use the offset of 0. There's offset. I don't really need to offset them, so I'm going to just set it to 0, basically to copy those 3 faces. And then if I hide that solid body, now I've got those relative faces that I can work with. All right, there's options to, if I grab an edge, there's an option to untrim surfaces, which is kind of like an extension, but it continues the face. So if this was a curved surface, it would continue the curvature of the surface. In this case, since it's kind of triangular, right? It continues that surface direction. So I'm just going to kind of repeat that command on all these, just hit and enter. Oops, I don't need that whole thing. Yeah, if I hit the face, look how it untrims it to a big rectangle, right? Because every surface body is actually typically rectangular in the background. And it looks good. I'm just using the repeat command with enter, right? Okay, so now what? Well, we can use some fillets. Because a face fillet's really handy here, especially where these are not, they're not going to line up nicely. I can't trim these to each other. You can only trim surfaces when they actually completely cut through each other. And those don't, but yeah, I'm going to make it sheet metal anyway. So I'm going to use a face blind fillet. But here with surfaces, you have to be a little careful about the direction. These little arrows need to be going in towards the radius. That's why I'm not getting anything here. And let's go like, I don't know, 5 millimeters. Just flip those around. There we go. And we'll repeat that on this side. And if you see me do anything that you're thinking, wait, what did you do there? Let me know. I'm kind of clicking through some of these options quick.
The trim extra.
Because it's a fillet, just like a fillet on a solid body kind of takes care of the surrounding geometry. As long as you see the preview direction, and that's why in this case, I've got to make sure it's going in the right way. Ooh, I'm going to get something weird there, actually. I didn't even notice that when I untrimmed this surface. I'm not going to get what I want. So let's go back to that untrim. Which one was it? I don't remember. That one. Let's see if I get, no, I do want it merged. I just don't want that big tail out there. Oh, you know what? This is 2 edges. I didn't notice. I should have noticed this because I've done this a million times. There, now let's see if it'll still figure out that radius. That's better. Okay. Yeah, but from here, you can take any surface and thicken it. This is also a really slick way to deal with a bunch of other modeling conditions when you just need the geometry to be thicker somewhere, thinner somewhere. You can thicken and cut, you can thicken outward, and now the sheet metal features work just fine to say, hey, insert bends in this thing. Because now it knows these are all 5mm radii, right? Wow, where's my, I saw something. Oh, I did this twice. Oh, I guess you shouldn't try to flatten the bends before. Let's get rid of this stuff, see if I can. Oh, I was probably going to get rid of all this stuff. I should have paid attention before I started, huh? Oh, right, because I left the solid body. I should have deleted the extra solid body. Where's the original one? There's the original one. There's an option to delete a body too, if you weren't aware of that. So I can get rid of that. Now let's try and flatten that again. Insert bends. That's what I was looking for. So yeah, it's a little more work, but when you've really got to get into something that's difficult, and I've spent more time than I would like fixing imported parts that imported poorly, had a bad face somewhere, so I had to delete it and then recreate the face. But when you need it, those tools are really handy. Show you a few other ideas. Skip that one. You can extend faces and use them to trim. So if you wanted to continue a countersink, I actually think in this case, a delete face would be a better option because you could pick that underside face, use delete face, and it'd clean that pocket right out. Replaced face is pretty cool. If you haven't used this before, you can, any part you have, right, you can make some other contoured surface and then replace the face of the part with a surface body. So, you know, got to revolve here. Pretty simple, but a flat face. But maybe I need it to be sculpted on this side. Right? Okay, well, we could revolve a little more on and then do a cut from the side. You can just do this because this way you'll avoid creating extra faces, even if it doesn't intersect completely. Right? This is not just cutting with the surface, but when you replace the face, there's a specific replace face tool. That's what you end up with. Right? It just takes the existing flat face and just replaces the definition with whatever that face is. And it can be a multiple surface, multiple face surface. It can be complicated if you need it to be. It can be a really handy way to take a simple shape and make it much more contoured with a replace face. Even with something like this, this is an imported helical shape, right? Stick a face out here a little further and use replace face and extends everything out, even though it's still flat. Continues all those faces out. Do something where, you know, trying to extend that thing, if it was imported, it's a little more difficult if you don't know about replace face. Can't just stretch it. This one, I don't know that this is so exciting. You can take a surface, offset it, extrude up to it. Okay, I don't know that that comes up that often. But this is one that I want to show an example of. You ever had to try to figure out how much volume is inside of a part that you've modeled? I mean, this is an obvious case, bottle, but a tank, a pan, or whatever. If you're trying to figure out the volume, well, the intersect tool is fantastic for this. Literally, in this case, all I have to do is make a plane, use the intersect tool, and say, "Hey, intersect my plane and the bottle," and it'll give me the volume inside. This one I want to go through because there are a couple little tips that I find fascinating for myself personally, but see if this is beneficial. Not recent. While I'm getting this, feel free to pop out any question. Where's my, oh, there it is. Questions you might have, or where's my bottle? There it is. The guy that gave me these models gave them all to me as template files. I don't know why. Doesn't really matter. It's still the model. Any of you guys taken the advanced surfacing class? This is one of the models you get out of the training class. Okay. If I want to figure out, you know what, how high do I have to fill this thing to get 700 milliliters in that bottle? Okay, so let's figure out. I've got a plane at the bottom. Hope you're all aware is a quick way to make an offset plane. Hold down the control key and drag an existing plane. I don't know how far I'm going to have to go, so I'm just going to make one. Okay, got that selected. And if you don't remember where insert is, or sorry, intersect, you have to remember what it's called though. Right, you can use hopefully you use the search tool occasionally for your commands. This is pretty slick. I can take multiple bodies, surfaces, faces, planes, and then I'm going to create an internal region. That's the option that I need. Tell it to intersect this thing. Okay, you kind of see the preview of that. That's exactly what I want. I want the guts inside. There are quite a few options here. Create internal regions, create both, cap openings. The default selections work just great for just a basic internal volume. Now, I'm actually going to delete this body for a minute. Not just the face, but the whole body. Because what this will help me do is use, let's change my units here for a second. So I think the default units are not in milliliters for volume. Yeah, cubic inches. That's no good for, not microliters. Milliliters. Okay. So I can come in and get mass properties, right? That everyone probably knows how to do that. There we go, 685 milliliters. So I'm close. Now, I don't want to have to keep jumping back and forth to the mass properties tool. Any ideas what I can do to help make this easy as I kind of tweak the plane to get my volume just right?
Convergence tool, there's a way you can just tell it to approach the solution within a percentage and then just let it do it. I forget what it's called.
Okay, I'm gonna give the more redneck approach. I don't know. Maybe it's not really redneck. I mean, because it takes a few steps here. But any other ideas? I'll show you. But I'm gonna go to file properties first. And let's make one called volume of water. And for the value, I'll just go with volume. Okay. And let's put a note, oops, a note out on the screen here. And link that to that custom property. Volume of water. I'll even put the little milliliters in there. So now, while I'm editing and I decide, okay, I want it to be a little more full. So let's try, I don't know, let's try that. Wow, that was a good guess. I'm pretty much there. I'm going 700 milliliters, right? But that way the property is updating on the screen so I can see it. So I was expecting to have to mess around with this number a little more. Right, but then I know exactly how far I've got to fill this thing to get the volume that I need. So whatever that ends up being, I can't remember what the number was. I was messing around with this earlier. I think it's maybe like 8.7. Yeah, that's pretty close. If I can tell, maybe make a mark on the bottle, do whatever I need, say, hey, it's got to be filled to this level. And then I've got the volume. All starting with the intersect tool, but then having a note linked to a custom property, which is driven by the volume of the part. Now, as soon as I suppress this other delete body, it's going to jump up to the entire volume, including the volume of the plastic of the bottle. So, okay, it was handy while I was figuring out the volume, but otherwise, I can ignore it. Intersect, that's pretty handy. Whoops, that's not what I wanted. Hide. There it is. Let me see here. This is another common use, like thicken, like the sheet metal part, but this is, if you're dealing with multi-bodies, this is a great example of multi-body. Use it for the master shape of a plastic part, but I don't know. I didn't hear a lot of feedback from the team that this is what you've got to do. To make an overmold, like in this case, thickening to really kind of intersect in slightly to make a pocket. So thickening as a cut, and then using the same surface to thicken geometry out. So you've got maybe the rubber overmold body as a separate body and the plastic housing. Okay. So it can be complex shapes to do the same thing. And this is a multi-body example here. I won't go through that one. I've seen some crazy ways to use surfaces too, but I'm going to skip through some of these. What are we doing for time? You have any favorite surface use cases you have? This is a crazy one too, but I'm not sure if there's not much interest in making plastic injection molded parts, or in this case, thermoformed parts. I won't necessarily go through all this. Yeah. Okay. Well, I'll show this one. This one's pretty cool because this doesn't require any. Oh, okay, there's one suite in this. No lofts. Nope. The only thing that's really used is a split line for a hold line fillet and some surface thickens. One suite for the rim around the top. Let's take a look at this approach. And I'm going to come back to this bottle idea. If you had to make the bottle in the first place. Keep losing my folder. No, not this one. This one. Definitely is a strategy when you're dealing with contoured shapes like this. Absolutely use symmetry to your benefit. So this thing really has quarter symmetry, right? So you'll see in the model, the way that it was done is just a quarter. It's just an extrude with draft. Nothing terribly exciting. But I've got some sketches over here that I want to use to represent what I want on the side as kind of those curves, right? So you've probably used a split line before, right? You can take an existing surface and model anything and split it up. Right, those are all still the same, in this case, same planar face, they just have more edges on them. And has anyone ever used a hold line fillet? So this is a fillet that you can apply around this thing, but using this edge as the tangent boundary. So instead of putting in a dimensional value, you're putting in an edge or a curve as the driver of the fillet. So if we just take a quick look at this thing, you pick, in this case, I had to pick a couple faces up here. For the one side, it's like a face blend fillet. Pick the other face set down here at the bottom. And then in the fillet parameters, you can choose a hold line. So then you just come up and pick these edges, and that's what defines the radius. Not, you don't input a number at all. Right? So it's just, I mean, it's pretty slick. That's just a fillet. So now we want all these kind of step walls, right? Exactly the same wall. We just want them out a little further. So that's a great place for just a surface thicken. There's a little bit of like subtle difference between a tool called surface knit and surface offset. I used to use knit all the time rather than offset. Knit is basically a way to just copy faces of a solid. So if I wanted to create a copy of these solid faces, I could just pick the faces and use surface knit, and there's no offset option, and it just creates a copy. Okay. I tend to use offset now because then I have the flexibility to offset if I want to. But these are already created, so I don't need to recreate that. So they created basically surface copies for all three of those sections, and then just did thicken operations with an increasing wall thickness. Okay, this is all still just a big solid bucket, right? Smooth that out with some fillets. Cool thing is this was done years ago when our fillets were not quite as robust, but now it would work very well to also continue that same fillet. Although I think, yeah, have to actually pick a couple extra faces. Or sorry, edges. That one doesn't tend to continue for whatever reason as well as it should. But we'll just pick those inside edges and make that a little better than the original. Grab another one over here so it continues. Cool. Okay. A couple mirror operations to then get the whole shape. Shell, easy enough just to make that thin, and then swept brim around the outside. So, you know, if you looked at that and somebody presented this to you and said, no, we need you to model this, you know, hopefully some of those ideas, like when you see stepped walls, if they're uniform to the shape, see if you can use a surface thicken rather than having to try to sweep your own surfaces around all that stuff. That would have been really painful. Okay. And that shows some examples of how that works. Blah, blah, blah. So let me kick over to a little bit of what's available now in the 3D Experience cloud-based tools. Okay. I think the coolest thing about us moving to the cloud-based roles available on the 3D Experience platform, and I don't know, who in here is 3D Experience, is that term just foreign to you? You've never heard of it before. Okay, at least you've heard of it. Okay. This is kind of the flagship development environment now for Dassault Systems, the parent company of SolidWorks. And it's the way they connect all their brands together, let's say for the future, okay? So the 3D Experience platform is a web-based, it's your data management, your PLM, you can run your CAD right in there. CNC manufacturing, just everything. There's so many brands at Dassault Systems for manufacturing and design. It's kind of staggering to some of us, but let me just show you an example. In this case, I'm going to start with something a little simpler. Do I already have this up? Yeah. I'm going to start with something just a little simpler with that idea of the bottle. And if you had to actually model that bottle, I'm going to give you a little bit different technique. So you can see I'm just running this on a web browser on the guest Wi-Fi here. So this is different, right? This is not my installed SolidWorks. There's a design tool that you can model just like you do in SolidWorks here. I'm going to be using more of the it's called subdivisional modeling. You've heard of the term before. It's the same technique that game designers use to design shapes for games. But it's called subdivisional. And you'll see that it's a totally different approach. Now, here I still have a lot of the same capabilities that you would see in SolidWorks for extrudes, revolves, sweeps, and everything, right? Surfaces, assembly, features, and everything. But subdivisional modeling is you start differently. You start typically with a primitive shape. Okay. So in this case, I'm trying to make a bottle. Well, let's start with a cylinder. That seems to be the obvious choice. So I start by placing this thing. I used to do something weird. It's not where I wanted it to go. I wanted to be able to flip the direction here. Well, anyway, ignore my hum-hoing. So let's ignore all this stuff for a minute, okay? It's all about taking a shape and deciding where to crease it and where to not crease it. That's like, and where you put those little divisions in a shape. There's nothing about like dimensional stuff. I mean, there is. I can still say, you know what? Let's have this thing be, I don't know, 205 millimeters tall, and let's have it be maybe 110 wide. I got to move it. I didn't place it in the right place, but that's okay. So I'm just starting with kind of a big chunk, and then it's all about, like I said, creasing and this robot manipulator. Okay, so this robot manipulator lets me move things on the screen, and I'll get more specific here. Let's see. I'm going to make sure this thing is pretty darn close to some of the guides I want to work with. Okay, but because it's surface modeling, it is much more about the look than it is about precision dimensions. Okay, now if you're the kind of person that drives you crazy, stop looking, stop watching. Because it's going to be all about like this. I mean, because if you're making a bottle, it's more about the shape than it is the exact precision size. And then it's grabbing these cages, getting a weird display thing going on, and then manipulating them. In fact, in this case, I want to actually manipulate them so that they match up with some sketches that I have here. So I'm going to take that boundary and say, hey, I want it to kind of match up instead of these vertices. I don't want that. I want some edges. I'm not getting the behavior I'm expecting here. Something's going funky. I don't know if it's hang on. Jump out of that for a second and jump right back in. Okay, we'll select those. snap them to, there we go. That's what I'm looking. And I'm going to kind of do the same thing down below because I want that bottom part of the shape to match more of like that oval. I'll grab those tangent edges. And this is just a quick way to say, hey, I want to kind of match up some existing shapes. Okay, but you can see it's kind of rough. So then to adjust, I'm not seeing my cursor preview going there. I can move them in symmetry by grabbing the little robot manipulator. It's all about this little robot manipulator and how you grab it. So those little dots move it in symmetry, while the arrows, I'll show you on another example, can really be used to help you tweak out the shape. So, okay, so now I've got the kind of top and bottom about what I want. A lot of your keyboard shortcuts work the same way as SolidWorks, F for zoom to fit and all that. And now I'm going to start tweaking these cages. So I'm going to take this middle cage. I want it actually a little higher, and I need another one here in the middle. So you can add subdivisions either by subdividing an existing region. And now let's take this thing, even shift arrow keys, right? Rotate by 90 degrees. And let's go kind of pull this in a little ways. What's that looking like? Let's take this one. You can kind of see the idea here. I'm going to make that one pretty narrow. Make a little neck on this. Oops. Nope, not trying to align anything. It doesn't look as pretty as I want. So it becomes this this kind of push and pull. And let's go. I want that a little fatter out here. Let's go like that maybe. And certainly like having somebody's sketch idea or something to work to. Here I'm just kind of eyeballing this off the top of my head, right?
But you can kind of have sketches and then do all this. And I'm going to assume you can then later put in some constraints that are hard constraints.
Well,
Right.
a shape like this is much more about just make it look good, right?
No, because I have to manufacture it within
Mhm.
certain constraints, not all of them,
Sure.
but like the height.
Yeah.
Maybe
Yeah, I have locked in the height, right? I've locked in the height at 205 millimeters.
Right.
So it's more of some of these other things that I'm doing, like for example, here in the middle, I want this to be a little narrower in the middle. So this is more of just like, hey, does it look right to make the bottle that I'm looking for? You know, I don't know if you've ever had somebody come to you with a design and say, hey, you know what, can we just tweak this a little bit, especially if it's a contoured shape, and you're like, oh, the features I used aren't really going to work for that. But you can see what I can do here. I can just kind of go, what? Let's do it about that. Now I'm holding the bottom and top. And here's where really the power comes in is, for example, the bottom. In SolidWorks, this model, we showcase the what's it called? Curvature continuous fillet, because we want it to look really nice. Well, everything in this tool can be either creased, or you can use that same crease operation to make them curvature continuous. This technology comes from the same stuff they use to make auto body surfaces for using CATIA. It's the same kind of technology. Okay, so I'm basically saying, hey, about what kind, now this is going to be surface milled in a mold, right? I mean, I'm not trying to make a 5 millimeter radius for a ball end mill. That's not what I'm doing here, right? I'm trying to make something really pretty. The one thing that they never do in that course is say, okay, now most bottles have that little dimple on the bottom. So when you fill it up, it doesn't pop out, right? That nice contour in there. So let's do that. Super easy. You know, consider if you were doing that in SolidWorks. I think I caught an edge there too. What would you do to make that contoured dimple on the bottom? Well, here I can just add another subdivision and then just grab that point. Let's make sure I'm lined up XYZ and just pull it. So, okay, let's do, and I could certainly make that specific. So I could say, hey, I wanted that to go up 8 millimeters.
Right.
So I
see
could
the
be,
I see the power that you don't constrain yourself to get the look and feel in general, but then what I was looking for was the ability to later, wherever I needed it, that I could put a constraint on it so that it's not gonna move if I go tweak again some more. If I put a constraint like that somewhere on there, because I like that concave in there. But now, oh shit, I need to go tweak something out here. What if I don't want that to change? I've already set it in place.
okay, now that's the same, that concept is the same concept you would have with SolidWorks if you say, I don't want this to change.
Well,
If it's still
pretty much
editable,
SolidWorks,
it's still
everything,
editable, right?
everything's like that. I mean, everything is constrained, pretty much should be.
Yeah. So here I've
Here, you
started
have
off
freedom.
with a specific dimension sketch for the bottleneck. And so now when I extrude that on the top, okay, that bottleneck is exactly that size and diameter.
But you're saying I already know that because I use it as a,
I use that just like I do in SolidWorks from a sketch.
right.
Right, that's what I was kind of using to begin to say, okay, I want the top of the bottle to come up to where my neck's gonna be.
Yep, yep.
Because I want my neck to be a specific size, but everything between here and here is just pretty. Right, I'm gonna, for the mold for that thing, I'm gonna surface mill that mold. I mean, it's a bottle. I'm gonna expect to surface mill that thing. But if now I talk to my marketing team and they say, well, we want it to be a little more squatty. Well, if you had modeled that with surfaces in SolidWorks, it's not going to be super
Right.
easy. But in here, you just go, okay, well, we can make it more squatty. You want it like this, or you want it like this, or what? What do you want? You know, we can go nuts.
Yeah, so that right there leads into my question. It's great. Right now, it may look like that and say it's 350 milliliters. I still want to keep volume 350 milliliters, but I want to change the shape.
Yeah. So this could be then, now this does not have that same intersect command, but it's a model you can open up in SolidWorks and then do the same operation we did before. Because I can shell this thing here, or like with some of the other details, like if this were going to be a bezel, and inside you needed kind of your mechanical fixtures, not just the pretty shape, right? Okay, I might do the contoured shape here, then pull it into SolidWorks and make the mechanical features, the clips, the threaded holes,
But you can't.
I'm not
see that here. But you can't just see the volume here where I'm, say, right now, it's exactly 350 milliliters.
Yeah, that's a great question.
I want to swap.
Because we do have material properties here, or mass properties.
Be wider and the bottom to be maybe a little bit more narrow, or just change the shape, but keep the volume.
Yeah, because this, I mean, I definitely have the same kinds of tools in here. But I don't think I have the intersect tool that I would personally go back to SolidWorks to use. Because that's so handy just to say, okay, I'm not going to fill it to the top. I can get the volume of this shape, but I want the volume, you know, down at a certain level. I don't want it to look empty, but I still want to tweak these. So yeah, okay, that workflow, okay, that takes a couple extra steps certainly. But the changeability that you get with sub-D modeling, and let's.
So at least can you communicate? It's all SolidWorks, so this so you can reference this shape over into a SolidWorks model.
Yeah.
And then later say, oh, like we say, oh, I want to change this freeform shape between the neck and the base. So I go back here and change it, and I can go back and I can have that reference show up in my SolidWorks model, right?
Yeah. Now this will be, because it's been modeled online, right? If I pull this into SolidWorks, SolidWorks does not have this sub-D
Right.
feature.
So you can't.
So it's not going to
That's
be
what
as
I'm saying.
editable in
Can
SolidWorks.
you edit it, go back here and edit it?
Yes.
And then it will update in SolidWorks.
Yes, exactly.
Perfect.
Yep.
Well, that takes care of everything I was talking about.
Okay, cool. So it does get, the workflow gets a little more complicated because all of a sudden you're starting to use a couple different utilities to finish your geometry creation, right? But, you know, I extruded this neck on, put a regular old fillet, shelled it out just to kind of illustrate, yeah, you do still have all those capabilities. But now I've got the power of being able to say, oh, hey, let's just, I don't know, I'm going to maybe make this ugly, but let's bulge it out here a little more.
Why not include this into SolidWorks or have it totally different?
There is a technology limitation. I should probably be a little more careful about my up to next there. Now it's made a weird thing on it. There's a technology limitation in what you can tag into the SolidWorks code base, right? I mean, there were companies that did this kind of stuff for SolidWorks, and they didn't have this kind of power. So because Dassault Systems already has this power built into 3D Experience, they basically said, oh, well, let's make a package that's flexible with the SolidWorks data. Maybe let me give you another example that might be a little more illustrative, if you will, of the idea. I've got a SolidWorks model that I've saved into 3D Experience. So for any of you that have purchased SolidWorks in the last, year and a half, you likely have SolidWorks with cloud services, which is 3D Experience. Okay, at least you have the ability to get things checked in and version control and revision control your data in 3D Experience on the cloud if you prefer that. This is an example of a model that's been checked into SolidWorks or checked into 3D Experience from SolidWorks Cloud Services. And I can see because they've all got the SolidWorks SW on the side here. But I kind of like this foot cover, but maybe it looks a little too mechanical. And we're wanting this prosthetic foot to look more like a shoe. Well, have you ever tried to model a shoe in SolidWorks? It would be tough, to say the least. So with this sub-D technique, this is still just an assembly. So I have the same kind of functions, insert a part. I'm going to call this new cover and stick it at the origin there. But because it's a sub-D model, I'm going to use a different type of primitive. I'm going to use a box to start. Stick it at the origin here. That's my spot. Okay, but I'm going to change up the number of cages. I'm going to go really simple. And generally speaking, when you're doing subdivisional modeling, it's like making splines. Simpler, the better. Okay, so the fewer points, the more accurate. And I'm going to tell it to crease everything. So basically I have a cube. Not terribly exciting, but let's also scale this up to be about the right size. Oh yeah, I totally missed, didn't I? Let's go kind of long. I can manipulate this more when I get it positioned correctly. But I could put some specific dimensions in here. But that's good. Let's make sure I've got this in the right spot. I've been poor with my aim today. Yeah.
Reference pictures.
Say again.
Pictures.
It's really helpful. Yes. Like in this case, I've kind of got the foot there and the parts that I want to surround. So that doing it in context of a SolidWorks assembly is really beneficial for an enclosure, a housing, something you want to look pretty, right?
An actual picture that you found, like, make it look really similar to this picture. Is that something that you can do? I know that's something you can do in actual SolidWorks.
Yes. I can't remember where it is in here, if it's in Sketch, but I know I've seen some of my colleagues do that. I will say I'm a bit of a rookie at this tool. So even though I'm able to make a model, it really doesn't take a lot to learn how to do it. I'm not the best at this tool for sure. So I want to say yes. I'm stumped at where to point you, but right now I can kind of see it's not quite the right shape, right? So I'm going to use that same idea of dragging some of these around. Make sure that's XYZ, because I want these extensions to be, let's go about like that. Okay. But then you remember I was talking about this idea of creases. So I want some of these edges to be curved, not all of them. So again, it's back to this crease tool. Okay, and I'm gonna have, you know, I could have it super round or not very round at all. Start there. Okay. And then it's that same kind of push and pull. Let's kind of go about like that. Actually, I want this a little higher. I don't know, maybe we need to kind of pull this back a little bit. But I also want to curve in the middle here. So maybe I'll add another subdivision around this edge. So that'll divide that perpendicular to the edge. So maybe we'll do, I don't know, a little curvature. Okay. What I really want is kind of a stylized pocket up top, or almost like a rim around the outside. You know what? I want this a little wider. That looks too narrow for the geometry that I've got. So let's grab all that stuff, and that's where the symmetry is really handy. That looks a little better. So I'm just going to take this and subdivide these faces. Now, when you do a subdivision on a face, it kind of makes a racetrack. Don't have a better phrase than that. And let's also take these, since it's kind of a loop, and do one more division there. So this crease tool is pretty cool. It's not just for outside edges, but it's also for the shape of the subdivisions. So I'm going to actually sharpen up. I'm going to still have them curved, but I don't want it a big oval inside here. I want all these subdivisions to be a little tighter to the rectangle, if you will. Okay, so it's just the same crease tool, and kind of see how you can then adjust the whole thing. Now I could go into each individual one and pull it, but this is just faster. Okay. Now here's where it just gets really slick, because once you've kind of got the frame that you want, we'll select either the points or the contours or the faces that you want to pull. And you just kind of go, okay, I want something. It's kind of like that. Okay, and again, I've got the flexibility to say, well, okay, up here, I want it to be this, maybe a little more here, right? And it just gets a little more free form when you start moving things around. I'm going to pull that one forward a little. Right, so I think I've hit time here, but you can see how much different technique that modeling is. I can go through the exercise of adding draft on here. There's draft analysis, and then I would pull out the base a little bit until I see the draft analysis tell me I'm beyond the angle that I need. You can start saying, well, you know, this is okay. This is kind of a clunky square up here. I want it rounded like the toe. Well, you just soften up these two hard creases even more, and then start pulling things around to fit the body of the toe. But all done just right here inside of essentially a SolidWorks assembly. So I can make sure it's going to fit with what I have. But as a way either to just come up with a concept at first. I've heard people use this two different ways. I've heard them use it to stylize, sit with somebody in marketing or somebody that's going to say, I want it to look a specific way, and very quickly come up with the concept. And they'll either use that model, just like this one, shell it out in SolidWorks, add in the mechanical features they need, or they use that, and then if they want it to be a parametric model in SolidWorks, they'll pull it into SolidWorks and then use surface techniques around it to recreate something that maybe is more sketch and dimension driven rather than like this, where I'm just kind of pushing and pulling, right? So I've seen it used in a couple different techniques, but the speed that you can make changes, you know, for example, if somebody came to you now and said, well, you want that toe round, why'd you make it all rectangle like that? That bar is in the wrong place. There we go. So maybe I'm taking too much time now, but I can use that same crease tool and say, well, let's just uncrease those completely.
What does that model look like if you bring it into SolidWorks at this stage?
It's like an imported body.
So it's like an imported STL file.
Not STL. No, it's a surface body. So it's a watertight solid. So you could shell, you can add extrusions, or you can do all that kind of stuff that you would do with any other imported shape, but the control remains in this environment.
And you're still referenced to that. If you don't break the reference, you still
Yeah.
reference, so you can still go back and have all the latitude that you're showing right now.
Yeah, for sure.
Cool.
So you have kind of the best of both worlds, right? I can start doing the, hey, let's
Like
make
that.
this thing look really pretty. Let's add a little contour in there, and I mean, the fact that I can whip that out just by pushing and pulling things around. I've seen people make like total character, a dog in here, what stuff you would never typically think of as a mechanical engineer modeling. But now I have something that looks a whole lot more like a shoe than the original model. The original model looked like it was done in CAD.
So in SolidWorks, if I want to go through the mold generating tools, I can't use this model directly?
Yeah.
I can.
Yeah, yep. This is a solid body that you can use inside of SolidWorks to core and cavity a mold and all that. Yep.
And shoot out a split line and extend faces and do all the rest of that.
Yep, exactly.
So what did SolidWorks do differently? Because it seemed to me in the old days,
Yeah.
there was a huge disconnect between sub-D modeling and parametric
Mhm.
modeling. And you could use this as a reference, not too indifferent from just bringing in a picture. And you could, and then create the surface bodies or solid bodies, whatever you wanted to do.
Right.
And then use those to make the mold components, the core and cavity, ejector plates, all that jazz. So did SolidWorks do something clever, or is this just an indication of how mature the CAD world has become?
Let me see if I can answer that question. Because it's, a little bit of both. Because so what I'm running right here is not inside of my SolidWorks interface. Because to integrate this inside of SolidWorks, the UI as it stands, let's play a little imagine if. The development effort might be a scale of 8. Okay. This technology already was developed for the last 30 years by CATIA, which is used by all the auto manufacturers to make their cars. So they've been working on that technology, and it's a different modeling technique, right? Sub-D is it's not the same as what you guys do every day in SolidWorks. But the technology was already built. They had to do about a development level of 2 to get that into 3D experience, and another development level of 2 or 3 to now make that be able to connect with the SolidWorks data set. So what we get is a huge benefit faster than having to wait for years of development for them to put it into the SolidWorks interface, which I'm just going to say is getting a little long in the tooth.
Right, but also this has been a way SolidWorks has done some of its enhancements, you might say. They have purchased
Oh yeah,
other companies or technologies,
right.
and the initial version that we get is exactly like this. I got this tool over here and I got SolidWorks. Okay, I can import stuff. Then, get a little back and forth. Now it's part of SolidWorks.
Yeah.
So whether this will ever happen, I don't know, but.
Well, and the movement is moving more and more to cloud-based tools,
Yeah. Which,
right? So the CAD side of this, you could model all of this stuff on the cloud using the same tool set. The toolbars are just down here instead of up top in SolidWorks. You could do it all on the cloud. I could be running this on a Chromebook. That would be just fine, right? Because the processing is happening up on the cloud. For the younger generation, who was like, what the hell is a save button? I don't know what that is. I think this is going to be much more acceptable to future generations. I'm used to the tried and true SolidWorks user interface. I'm slower here
yeah,
because honestly, I'm used to where things are in SolidWorks, so I'm faster there. But as a person who shares data a lot, man, the flexibility of just having it on the cloud, and as soon as I model it and save it, it's all on the cloud. I can just send a link to somebody to view. I don't have to worry about them installing e-drawings. It's a lot simpler.
simpler.
I'm a little slower in this environment though.
When the data management gets just a little bit better in the cloud.
Oh,
versus-
the data management on 3D Experience is the same stuff that Boeing uses. It is as high end as you want it to be. It's pretty amazing. It's
As far as
the,
like revision management.
yeah,
Oh, we poo-pooed because of that earlier. Yeah.
well, I mean, it's what the big boys use. They're using, that's where this technology came from on the data management side and the PLM side, was from development for the auto manufacturers and the airplane manufacturers, Airbus, Boeing.
Yeah, I'm looking for the whole, basically the approval process, and that
Mhm.
seemed to be more simplistic in the 3D experience. I mean, it's okay, but if you were already geared for the last 15 years in the SolidWorks data management world,
Yeah. And that's, oh, I totally get that. And maybe this is a good point to have some side conversations, but there are probably some of you who are like, oh, I'm done with this. We're already this over. I'm happy to stick around. I hope that was interesting to see. So some surfacing tools in SolidWorks, they're great. I love them. But some of the stuff that you can do, if you've got 3D Experience SolidWorks Professional or higher, you've got access to this. It's in the Maker version of SolidWorks, so you can mess around with this Maker version. It's phenomenal. It's got its place though. It's if you make tooling, you're probably not going to use this. That's okay. If you make weldments, you're probably not going to use this. This specific tool, there's a whole weldments tool on the cloud if you prefer that. Sheet metal on the cloud if you prefer it. But I'd be happy to stick around. I'm not flying back home till tomorrow, so if any of you care to chat about where SolidWorks is going, any of that, I'm happy to do it. But otherwise, I hope you appreciated the sneak peek.
There is one question.
Oh, yeah. I've kind of been ignoring the, how do I get back? There it is. There's a raffle. Am I the only one that believes top down may be better than what we are seeing here, making push and pull models? Just asking, sitting in front of clients, I see making models this way being of value. Yeah, it's a fair point. I'm not saying that this is the way you should do everything by no means. Most of the stuff I've designed through my career, I would do it with traditional SolidWorks modeling techniques. But for the rare case, when you need to make something contoured and somebody's going to be sitting with you going, nah, that doesn't look as pretty as I want. But, there's a place for it. It's not for everything. So Ted, yeah, fair point. And in some cases, go with what you're going to be better at and faster at. If this was going to take me too long and I could do it faster in SolidWorks, okay, I'm going to use the tool that I'm going to be faster at and more confident with. Yeah, hope I caught the question well, Ted.